Good evening, everybody. Our original welcome address from our head of department, Professor Kennedy, was called away at short notice, so I'm just going to pick up her welcome to you all to the university. We have many guests that have come, actually some from South Wales, Kent, Sussex. So there's some people that have come a long way just for this evening, and I understand that there are no fire drills, so if the fire alarm does go off, go down the stairs and turn right at the bottom of the stairs out into the car park. There is a raffle. You have a raffle ticket, and the raffle is for this book. And the book is a book that commemorates the 60th anniversary of Sir Edmund Hillary climbing Everest last May, and it's written by his daughter Harriet Tuckey, and it's a fantastic book. So hopefully one of you will be lucky to receive it this evening. And then just to commence our proceedings, I would just like to say a few words about our chair for this evening, which is Professor John Summerew, and he's a professor of cardiovascular and sports medicine here at the university. His real work is as a consultant cardiologist at the Countess of Chester Hospital, and he's been involved as a tutor here on our programs in sports science, sports medicine, cardiovascular health and rehabilitation for about 10 years. And he's one of the country's leading sports cardiologists, and sort of in this region of the country, he deals with a lot of athletes, and his client list includes Liverpool Football Club, the Welsh Rugby Union, and some of the athletes from the British Olympic gymnastics team. So he is John Summerew is going to chair the evening. So if you'd like to come on up, John.
Right, well, it's a real pleasure to be invited to chair this meeting here today. It's great we've got such a wonderful turnout as well. You will hear this evening, you will hear a wonderful selection of talks this evening. I've been lucky enough to spend an evening with a couple of the speakers, and they came around to our house and discussed what they have been doing going up and down mountains. And in some respects it's quite exhilarating, in other respects it's absolutely frightening. And you will hear some of their stories this evening. All this came about because Marie Kristelle, one of our speakers here this evening, she's currently doing a fellowship here at the University of Chester, and also is in University of at the Council of Chester. She's been working with me as well. We did a cardiomyopathy clinic today. I've had her in my ear telling me, "Oh, we don't do that in Canada, we do this. Thank you so much, it's really good." But it's a great instruction that she's given me as well. She's had a few problems with visas, but we've allowed her back in the country purely for this talk, no other reasons at all. And she mentioned that to John Buckley that she does a little bit of climbing, and that her husband does a little bit of climbing, probably the understatement of the year. So that's where it all came about, and from the discussions with her, we've now had this group of speakers for this evening. I'd like to introduce the first speaker this evening, Jonathan Walton. He has some titles which I don't understand. Geospatial engineer, which he will tell us about. He has been trained and has a degree in civil engineering from Imperial College, and also land surveying, University College London. He served in the British Antarctic Survey as a glaciologist, wonderful titles, and a surveyor. In fact, he's just come back from Antarctica as well, and hopefully he'll tell us about that. He's received the Polar Medal and appointed a Fellow of the Royal Geographical Society. In addition, he and his wife organised tandem triathlons, which I don't think he's going to be talking about tonight. But anyway, without further ado, it's a pleasure here to introduce Jonathan, who will hopefully tell us where Everest is, and does it appear to be the tallest mountain. Thank you very much.
I have got an impossible job this evening. Normally land surveying, which is the older term for geospatial engineer, but I like the new term because it nobody knows what it means, is a 3-year degree course. I have 20 minutes to teach you all I know about land surveying. Actually, that would only take 10 minutes, but a lot about land surveying. Mount Everest, how do we know it is number one? How do we know it is the highest in the world? I'm just going to give a very quick background about how it was found and mapped by the Western world. Surveying, a very brief introduction. In the until the 1950s, you could measure two things. One was you could measure distances, really difficult to do accurately. The other thing you could do was measure angles. That's basic surveying. You measure distances and angles, you put them together, you wind handles or you press buttons on a computer, and out come the results. It was a lot more difficult in the 1800s. Distance units, we're talking about India here, 1800s, feet. That's easy. What's more difficult is that the definition of the foot varied from 1806, the Madras foot, to the 1824 Dehradun foot, to the 1853 Delhi foot, and they're all slightly different. And when you can start to look at the old Survey of India results, working out which foot is which, just saying their feet, that's about. And until 1950s, the only way you could measure distance was with a 100-foot tape measure. And that's all they had. For anything in the whole of India, they measured all their distances with 100-foot tape measures. But if you put a 100-foot tape measure about 150 times end to end, and you do it incredibly accurately, and you take into account the temperature and the strain on the metal and the sag of the metal, and you can, after about a year, you can measure an 8-mile long baseline to an accuracy of about, well, let's go metric, 2 millimeters per kilometre. So that's the sort of accuracy they were working to. But it would take a year to measure the baseline. Angle units, much easier. Degrees, minutes and seconds. Well, that's not. But let's just try and clarify. We're just trying to. I want to really clarify tonight what an amazing feat it was to survey Everest and the mountains. 1 degree is 1 in 57. That is 1 metre. If you were to stand 57 metres away, the angle between from one end of the bar to the other is 1 degree. Okay, what's a minute? If you go 3.5 kilometres away, one end to the other, that's 1 minute of angle. A second's a lot less than that. For a second, you've got to go 206 kilometres away. So you can measure with a theodolite, which is the instrument we use for measuring, you can measure 1 second. In other words, the accuracy of an angle measuring device is such that it would pick, well, maybe not at 206 kilometres, but it's that sort of accuracy of angles. And theodolites are wonderful things. That is a theodolite made in the 1970s. Precision instruments, but they've also got to be rugged because they've got to be used in the rain, they've got to be used in the snow. That particular one I used at 17,000 feet in the Himalayas, and I carried it up, and it still works. And I can do this, I can do this. Things fall off, but it still works. And it is a very precision instrument. That is a glass circle, very carefully divided. However, if you're really in difficult places, this is a much nicer theodolite because it's so much smaller. That measures directly to 1 second of arc. This is a much smaller theodolite, but infinitely nicer to use if you've got to carry it on your back. Really. That measures to 10 seconds of arc. But still, 10 seconds of arc, that's 1 metre at 20 kilometres. That's a pretty accurate bit of kit. Now, the Great Trigonometrical Survey of India used that theodolite. It weighs half a tonne. And though they carried that all over India on a bullock cart to measure their angles, they didn't have any of this modern gadgetry, and they carried that. And they also built towers 50 metres high, hoisted that to the top so they had better visibility on the flatlands in the centre. Triangulation. Now this is the building blocks of surveying. We're really moving quickly here. If you've got here 2 fixed points, you know that point and you know that point. You know their position accurately. You therefore know the distance between the two, right? If you then set up an instrument on this one and you measure an angle up to that one, if you now set up the instrument on this one and measure it to that one, bit of trigonometry, sines and cosines and all that thing you can perhaps remember from your youth, you can calculate the position of this one. as a bit of a check, you set up an instrument on that one and measure that angle as well. Now, who can tell me what the internal angles of a triangle add up to, please? Wrong. When it comes to surveying, you're wrong, because the Earth's surface is curved, and if you think of a triangle, an enormous triangle with one point at the North Pole, one point on the equator, and one point on Greenwich, and one point in the equator at 90 degrees east. If you think about that shape, the internal angles of that triangle are up to 270. In other words, the size of the triangle affects the number of degrees in a circle. All these are intricacies that the surveyors had to cope with in the 1800s, surveying India. Now, if we've now got measured a third point here, if we now go, we've now got 3 fixed points. We now know the distance between these two, and we do exactly the same. We've got another unknown point up here, another couple of angles. We've now got another point. So you build up a chain of triangulation. And now until the 1950s, that's how surveying was done. The whole of Great Britain was surveyed like this. India was surveyed like this. And the main mover of the Great Trigonometrical Survey of India, which is one of the most amazing feats of engineering of the modern world. If you get a chance, just Google it and start reading about it. It's an amazing feat. Was Sir George Everest. And that's his worship, and he was the main mover for 24 years of the Great Survey of India, and that's some of the sort of typical pictures from the Great Survey of India, and that's what they did. Those are, you can see them, chains of triangulation stretching over the whole of India. This is all done from a single very accurate baseline down here near Madras. This took them, well, to get right to the top, it was about 50 years' work. But that represents up to several thousands of people. They had to do it at night and shining lights. Well, they didn't have torches in those days. It was lanterns because the air isn't so shimmery at night. So an unbelievable feat of engineering. Now, the bit we're interested in are these big long rays up at the north here, because they got to the foothills of the Himalayas, and all they could see in the distance were these big peaks. And they thought some of those look quite big, but they couldn't get the theodolite to those peaks, so they intersected the positions of them, and those are the peaks around Everest, and there is a triangulation chain that we've just been talking about, and then they put the theodolite on each of these in turn, and did intersecting rays out to the great big peaks. And you're just about to ask me which one of those is Everest, and I haven't a clue. But it's one of those. And we're talking about distances here of certainly in excess of 100 miles. So we're talking, looking out at a whole series of peaks, a whole line of peaks. They don't know where they are, and they don't know how high they are, but they can measure this using these surveying techniques. And that is a slightly stylized one. There's the triangulation. And there's the triangles here measuring to Mount Everest. And you could fix its position with just 2 lines, but they do it from 6 or 7 and then work out the best solution from 6 or 7. Now, this is a typical of what they would have seen in the Himalayas, but it was one taken from a job in the Antarctic, where you're surrounded by mountains, and this was to surveying a runway, and all they wanted to know was how far away were all these mountains and how high were they? Well, these look the bigger mountains, but of course these ones are further away and they're actually much higher. And that's exactly what the surveyors were doing in India. They just had this long line of peaks, and from that long line of peaks in a panorama view, they numbered them. In the Himalayan chain, I think it was 1 to 18. Peak 1, peak 2, peak 3, and it actually got to peak 15, and they found that peak 15 was a little bit higher than, a bit further away than all the other ones. That turned out to be fairly significant. In the Karakoram Himalaya, they did a similar job, and they called them, rather than just repeat the numbers, they called them K1, K2, K3, K4, K5. Have you ever wondered where the name K2 came from? It was from the surveyor, Mr. Godwin Austen, in the 1850s, and it was the number 2 in the Karakoram panorama. That was as simple as that. When you go into the mountains, when you're doing any surveying, things aren't what they seem to be. And this is really important. When you're standing here, the air, the light coming from the top of that mountain to you comes along that red line, and it's not a straight line. It's refracted because of the density of the layers of air changes the refractive index, and the line is bent. So actually, if you look from here, you will appear to see that mountain right up there, but actually it's down there. And this we're talking about at 50 miles, hundreds of meters. So a massive change. So things aren't what they appear to be, and you've got to know the refractive index of air before you can start adjusting your calculations. In addition, you've got the Earth that's curved. And so there's the vertical lines going from the centre of the Earth up to where you are. You're just here, and you're looking out exactly horizontal. Look, you're looking out exactly horizontal, and just below the horizon is this mountain. So looking at it, you think, oh, the mountain's not as high as we are, where it's quite obvious that actually the mountain is a lot further above the sea level than where you are. So again, things aren't as they seem, and you don't know all these things. You don't know until you start crunching the figures, which in 1850 was using log tables. And at the top of the distant mountain, it appears to be lower than where you are. And the other one is a simple one. You're looking at two mountains in the distance, and you don't know where they are relative to each other. One may be in front of the other, but when they're 100 miles away, it's very difficult to tell. And you look out, and then there's the verticals again, and it appears that the nearer mountain is higher than the first, but actually it isn't. And that's what happened with Everest. They looked out upon these big mountains, and one of the more distant peaks was a bit lower. And until they'd done all the sums, they didn't realise that actually the peak B was Mount Everest, and that was the highest one. So it's a long, and it's very, very tedious. The surveying that they did is incredibly tedious. To get good answers with a big theodolite, or even a smaller theodolite, you don't measure the angle once, because that's not accurate enough. You measure it 8 or 16 or 32 times and take the average, and the average is going to be not far from the truth. So everything is incredibly tedious. It can be a really good adventure going surveying. I did a bit of high altitude surveying, which I'd like to share with you, because it's interesting and it's some good pictures, really. And in 1910, the Russian Empire and the British Empire decided that they ought to link their empires via a survey triangulation. And this is a survey triangulation that goes right up over the Karakoram Himalaya. This is Gilgit, this is the Hunza Valley, and up to 19,000 feet. So the Russians came down from the north, the British came up from the south, and they met on the border. And it's an amazing, and some of these triangulation stations, I went to them in 1980. Some of them are a bit difficult to get to. The paths are very difficult, and you're walking along there carrying a theodolite, and then along comes a family, parents and 3 kids and a herd of goats, tripping along, not a care in the world. Health and safety, forget it. But walking that path was one thing, building it would have been something else. And this was one of the survey stations I had to get up to. This is what they did in 1913. And I got there and I said, well, I know it's on a pinnacle on that ridge. And they said, one of the shepherds said, yeah, my grandfather went up there with the Saabs. And in fact, he said, I think it's this one there. And we did indeed walk up. Now, if you can see very carefully, it makes some wonderful views because it's a bit light, but right in the middle there's my tent, looking right over Rakaposhi. So it does, surveyors get to some wonderful places. You've really got to get to the summits of mountains to get the best survey positions. So it's a great excuse for getting someone else to pay for you to go up mountains. And that was 1913. This was typical of what they would have seen in the Great Trigonometrical Survey. And this was the Russian surveyors and the British surveyors meeting on the border at about 18,000 feet. And they carried those big logs up there to be a beacon. 1980 was a different sort of beacon. We carried these up there. And that theodolite is in fact the one on the table here. And that was up at about 16,000 feet in the Karakoram. And again, you can see the sort of airy positions you get to. This was the highest place we went to. That was the picture of the one I showed you on the top of that pinnacle. I want to share with you the description that they wrote about it in 1913. Attabad Station. 4 days of bad weather now kept me at Gulmit, and on the 30th day of July I marched up to Attabad village, while on the following day I camped below the station, which is 17,000 feet and 11 feet above sea level. Attabad Station is built on the summit of a pinnacle of rock, and is the nastiest place from which I ever have observed. The rock stands up from the main range and can only be scaled with great difficulty. The flat portion at the summit is only about 4 feet by 5. On one side, the approach is in the form of large loose rocks resting at very steep angle, while on the other 3 sides there's a sheer precipice of 1,000 feet and more. There's just room enough for the theodolite stand, and I had to erect a temporary platform about 1 foot wide on bits of wood in order to enable me to move around the instrument. The observations were completed on the afternoon of the 2nd of August. So that is typical of the sort of places that surveyors have to go to look out over distant peaks. And that was Chen Jianming. We were an international expedition. He, in fact, was the person that made this map, which was never seen by the Western world until 1980. That is the Chinese map of Mount Everest, 1 to 50,000, and Chen Jianming made it, and he climbed to nearly 22,000 feet on the slopes of Everest to take the relevant photographs to put together that map. So that map is, thankfully, it matches very closely the map that the Royal Geographical Society made earlier in the century. So they were very relieved about that. But Mount Everest and any mountainous areas have a great difficulty with the surveying of them. That's the map, bit washed out there. Surveying 21st century style is a very, very different game. Everything nowadays is done using GPS, global positioning systems, and they are very accurate. You climb to the top of a mountain, you put a pole there, you press a couple of buttons, and it tells you where you are, latitude and longitude, and how high you are, to a few meters, 2 to 3 meters. If you use GPS in the right configuration, differential, you want to find the position of one point relative to another one, you can start using GPS much more accurately in about 2 to 3 centimeter accuracy. Nowadays in UK, you can have a single pole, you can walk around, press a button, and it tells you your height and easting and northing on the National Ordnance Survey grid to 2 centimeters. And you can actually do something fairly similar in the Himalayas. It's just rather higher to get to the tops of the mountains. But they have been to the summit of Everest, I don't know when, I think it was about 2005, Rob, with GPS, and they've checked it all out. And nowadays, all you have to do is you go on Google Earth. If you go on Google Earth and hover over Everest and hover the cursor right on the summit of Everest, it says 8848 meters. So actually, surveying now is so different. It's unbelievable. I'm thankful that I was still there at the old days when they wanted to actually send me to these places and do the measurements. But it is a lot simpler these days. But I just wanted to give you an idea of the complexity of the operation to first of all map in 1853 the position and height of Mount Everest. Peak 15, number 15 peak on this panorama, it was first observed by Radhanath Shikadar, and he was the surveyor that first saw Mount Everest, and he then sent the results down to a computer, that a computer being a person who was very good at sums, down near Delhi. And about 1.5 years later, they came out to the Surveyor General and said something like, I think we found a peak that is probably higher than any of the other ones in the range and possibly the highest one on Earth. And that was the first time that Mount Everest was isolated as being something a bit special. Measured height in 1853 was 29,002 feet. The latest accepted height is 29,028 feet. For them to get that close in 1854 is nothing short of miraculous. But it actually, to me as a professional surveyor, it shows the quality of the work that they were doing and the meticulousness that they did it with. Now the question I asked at the beginning, is it really number 1 Everest? Well, the number 2 mountain is K2, 28,250 feet. I am absolutely 100% confident that Everest is the highest mountain in the world. And I think on that stage, I'll leave it to you. Thank you.
Okay, John. Well, thank you very much, Jonathan. I mean, that was an absolutely wonderful overview. And it's nice to know that Everest is number 1. What we're going to do is we're going to take questions at the end. Left that there, thanks. We're going to take questions at the end, have a panel discussion at the end. Moving on to our next speaker here, Dr. John Buckley. It's my real pleasure to introduce John Buckley. This is the first time I've been able to introduce John. He's introduced me before countless times. I'd love to tell you loads of stories about John. They're all illegal and immoral. Known John for many years now. So I can't unfortunately give you any of those stories. John originated, there's a bit of a theme here, from Canada, and had degrees in physical education and sports science, exercise physiology, the University of British Columbia, Loughborough University and Keele University. He is an avid lecturer. If anyone has heard him lecture before on rehabilitation, it's wonderful what he has done. In fact, he has been the past president of the British Association for Cardiovascular Prevention and Rehabilitation. He's the current founding chair of the International Council of Cardiovascular Prevention and Rehabilitation, and that's made up of 19 national associations from all 5 continents. Bits you don't know about him, things such as he was a county tennis player. Not to look at him now, but he was a county tennis player. I don't think I'm going to sort of dwell too much and bring up John's past, so I'll just say over to you, John, and he's going to give us an overview on oxygen. Is it good or bad for you? Or something akin. Recognise any of those?
No.
I don't know which one it is that one?
Yep. Thank you.
This one.
Thank you very much, John. It's the problem is the photographs and the pictures from all the presenters. So I've got some interesting photographs. Usually you show your holiday photographs, but these people here, their holiday photographs are out of this world, literally. So I've got some interesting photographs for you, but I'm sure you'll spot them as I get to them. I'd just like to say, in terms of this evening, there's a bit of number of people have been involved with supporting this evening. Professor Sarah Andrew, our Dean of the Faculty of Life Sciences in Lynn Kennedy, our Head of Department of Clinical Sciences, Martin Degg, who's going to close out the session, hosting this in his domain here near geography, obviously our chair, John Summeroo, and 2 ladies that have been helping us on a lot, Moira Hazelton and Alison Morgan, who've been instrumental in all the important bits that go to putting on an event like this. So just to recognise them. But I'd also like to send a special thanks to our speakers, and actually more like friends. I only come by meeting these people, I think, by luck. Jonathan was a neighbour. Marie Kristelle wanted to come to England to do cardiac rehabilitation, and I think, as John was saying earlier, it was by luck that the rest of these stories seem to have transpired. So to look at this idea of oxygen and getting it to the bits that need it, I'm going to look at a bit of history of that, physiology, sociology, psychology, really just to provide a foundation for what Marie Kristelle and Rob are going to entertain you and highlight with you, and they are going off to Everest next week. So hopefully we'll be thinking about them with these things. But I did delve into a bit of history, and in 1905 they got to 7,700 meters. In 1909, 7,000 odd meters. In 1924, they got to within 300 meters of the summit of Everest without oxygen, and they only summited Everest without oxygen in 1978. So it took them 54 years to climb the last 300 meters. As the story goes, and we all know that in 1953, Edmund Hillary and Sherpa Tenzing Norgay were the first that we know of to summit Everest, and that always is that question, the first that we know of. It's a bit like the 4-minute mile that Roger Bannister, we say he was the first one that was recorded to do it, but perhaps there have been people that have done these things, but the good old British Empire always won out, I don't think, in those glory days. Anyways, there's the first interesting photograph. I can't do holiday photos, so I may as well do wedding photos. And obviously there's 3 notable facts in this wedding photograph. One obviously is Fiona, my wife, and still looking the same as she did 19 years ago. The second notable thing in this photograph are the hills, and these are the Stretton Hills in Shropshire, where Fiona's from, and many weekends of the year we go walking in these hills, and the average height of the Stretton Hills is about 400 metres. So in the past 20 years since we first met, I've worked out how high we've climbed, and it comes to about 120,000 metres. So that means that that's the equivalent of climbing Everest 13 times. So I think Rob's got another 5 times before he catches up with us. Anyways, the third notable issue in this photograph is the car, which is a Rolls-Royce 1927 soft top, which I believe. And you may notice the man driving it. It's Jonathan. And this is his car, his toy. And Fiona's there in the back, just arriving at the church. And you were ahead of time today, Jonathan, and I know that you were ahead of time. You were about 20 minutes early at the church at the wedding. So great panic. But anyways, this is Jonathan and his family, but this is at the wedding. So this is not now. This is 19 years ago. And Finn, his eldest son, he's been working in the Antarctic. And Tom, who's done astrophysics. And Ruth, the baby girl, she's a maths and a linguist and studying Spanish. And obviously Wendy Jane, Jonathan's wife, who's as a GP. So not your average family, plus the Rolls Royce as the family car. So anyways, this is Wendy Jane, Jonathan's wife. And this is her running the Comrades Marathon. And that's 2 marathons back to back. That's 87.3 kilometers or 2 marathons. So and you can see the time. They're 9 hours, 24 minutes, and 10 seconds. So you're probably wondering, well, what does this have to do with climbing Everest? Well, just to look at some of the facts, because it is related to oxygen. If you're doing that distance in that time, it's an average of running at a 10 minutes, 25 minutes per mile pace, or averaging 5.7 miles per hour. And a total calorie burn of about 5,000 calories in that race. The important bit is that she's requiring about 1.7 litres of oxygen every minute while she's doing that race. And that's for 9 hours and 24 minutes. About 9 calories a minute is the amount of energy that she requires. Her lungs, in order to get enough oxygen into the body to deliver that 1.7 litres, need to ventilate about 35 litres a minute. And her heart, in order to get the blood and the oxygen to the muscles that are doing the run, has to pump out about 12 litres of blood every minute, just in order to get that oxygen to her muscles. So there's quite a bit of work by the heart and the lungs in order to get that amount of oxygen so that she can run at that pace. So why is this relevant to climbing Everest? Well, on very reliable sources, I believe, the last climb to the top of Everest from the South Col is about 2,000 meters, but that takes between 9 and 10 hours, the same time as it takes to run the 2 marathons of the Comrades Marathon in South Africa. It's only a mile and a quarter in distance, and it takes you 10 hours. It's a 900-meter vertical climb, and again, the estimated calorie burn is about 4,000 to 5,000 calories. So that 1.25 mile dash, as it is at the end, to get you finally to the top of Everest, is similar in terms of 2 marathons, in terms of time, in terms of energy required. Now, if we look at the pace, under hypoxic conditions. So if we look at summiting Everest, you're 200 meters per hour. So if you're looking out to the hockey pitch, that's one end of the hockey pitch and back, and that'll take you an hour to cover that distance. Wendy Jane in the Comrades Marathon was covering that distance every minute and 20 seconds. And we know that the world's record for the 200 meters by Usain Bolt is 19 seconds and 0.19. So it is quite an effort, and the whole reason is because there is obviously a lack of oxygen, and that's the important bit that has to be supported. So it's just an amazing comparison going up to that height. So in terms of the issue of preserving this oxygen flow to altitude, both for survival, because probably most of the oxygen that they're requiring when they're up at that level is actually simply going into keeping the body alive, and then they're trying to use a little bit of that oxygen to actually do some exercise. So the organs that are involved in this, obviously the lungs, the oxygen's got to get in, the heart has to pump that oxygen, but actually the primary endpoints for this oxygen demand, which is very limited at altitude, is obviously keeping the computer going, the brain, and if that starts to fail, and we know that starts to fail because people start to lose their wits. They can't make rational thoughts. Perhaps that's why they all climb it, because once they get to that altitude, they literally lose their minds. So, but what's important also is that we need oxygen not just to fuel the muscles, but we need it to run the electrical system in the body. And when you think about the electrical system for managing the function of the lungs and the heart, if those start to go a little bit out of whack, then really there are problems. So it's probably a good idea. That's why Rob has married a cardiologist to make sure that now that he keeps his wits about him and is reasonably safe. He's getting wise in his old age. And the heart specifically, actually, the electrical system of the heart actually does require quite a bit of oxygen relative to its size. And we know that when that is impaired, that the heart function and the electrical system start to break down. But there's all the other electrical systems in the body that obviously you've got to see. You've got your eyes, and you've got kidneys need to be working reasonably well, and all these factors which will Marie Kristelle will tell you a little bit about the relationship of all those functions and people getting mountain sickness. But if we go back to the challenge of getting oxygen to the bits that need it, we'll review that. We've got Wendy Jane at sea level or near sea level, running 10 and a half minutes a mile. And her oxygen usage, we said, was about 1.7 litres a minute, and the lung ventilation about 35 litres a minute in order to get that oxygen in. And so for that long Comrades Marathon, she's probably only using about 60% at the most of her aerobic capacity. So she's got 40% left in reserve. But you can't really do much more than that if you're going to keep going continuously, or else you'll run out of glycogen and glucose. If you go to altitude and you work at the same level, what you see is that the lungs then, and this is at 6,000 feet, if you go to 6,000 feet of altitude, your lungs almost have to, they're about 30-40% more. They need to work 30 to 40% greater. And also your aerobic capacity starts to shrink. So then, even though you require the same amount of oxygen, you're now using 65% of your reserve. If you go to near 4,500 meters, then your lungs have to ventilate 85 liters of air every minute in order to get that same amount of oxygen in. And now your exercise capacity has gone down even further. So now you're using 75%. And then once you get to Everest Base Camp, for the average person at Everest Base Camp, their lungs are actually ventilating 100 liters per minute. Now, if most of you got your lungs to ventilate, if you can think the hardest you've ever exercised, and felt what your lungs feel like, well, actually, at Everest Base Camp, when you arrive there, that's if you're trying to move just at a nice steady, what you would consider a steady jog, that would be like a maximal exercise test, or pretty much near it for most people. And then basically, when you get up there, you literally run out of oxygen, and your exercise capacity is now down to 1 liter a minute, and the demand to move is 1.8. So you're now requiring 150%. So you're having to use a lot of what we call anaerobic energy to keep going, and that's why you have to take it in very small, short bouts, recover short bouts to try and get that last 2,000 meters. So what might this breathing feel like? Well, this is what we call an oxygen saturation curve at altitude, and if you're looking at if you're in an aeroplane, which is pressurized to about 10,000 feet, then your oxygen sats have dropped to 93%. Now, at rest, at sea level, your oxygen sats are near 100%. So if you think of somebody with an asthma wheeze, sometimes their sats will drop to about 93%. So you probably won't notice that a great deal unless you're trying to exert yourself. When you get to Everest Base Camp, your oxygen saturation in your blood drops to 80 to 85%. Now, if you went into your local hospital A&E department with an oxygen saturation of that, they would put you on oxygen, and you're either having a severe asthma attack or you've got something like emphysema. And that's just at Everest Base Camp. So that's the quality of the blood just at Everest Base Camp. There's obviously some acclimatization to that can happen with time, which Marie Kristelle will tell you about. But by the time you get near the summit of Everest, your oxygen sats are at 65%. So, you really aren't functioning fairly normally. And that's why the group from University College London, led by Hugh Montgomery, are like to do research up on Everest, because actually he's an ITU specialist, an intensive care specialist, and actually you can expose healthy people to what it might be like to be in ITU. So just to summarize this oxygen usage, you get a decrease in your aerobic capacity down to not much more than what you require at rest. Your oxygen saturation drops, and your lung ventilation, actually about 6,000 meters, something seems to happen to the ventilation, and I'm interested to see what people feel like at that sort of level. Remember, I have climbed Everest 13 times, so I know a lot about this. So who worked all this out? Well, in the 50s and 60s, a man named Griffiths Pugh, who the book is about, which is on for the raffle, and he was one of the early physiologists. In the 70s, 80s, an American West was leading it, and since 2000, this group at UCL in London, Montgomery and Grocott, have been doing quite a bit of work on the physiology related to this. And really the story was that without the science behind understanding this oxygen usage that I've just described to you, that was the reason they got to the summit in the first place, and understood, because they worked out how much oxygen you actually need. And so here's a picture of Griffiths Pugh with a Sherpa in those early studies, and he was comparing Sherpas with Europeans' oxygen consumption at altitude. And here's the book that somebody's going to walk away with tonight. Interestingly, at the same time as Griffiths Pugh was playing around with oxygen, so was Roger Bannister. And this is something that people often don't know, but he was in the lab at Oxford and at St Mary's in London on the treadmill and feeding himself and his subjects oxygen to see if he could understand better how to break the 4-minute mile, and was it possible. But he was actually experimenting with lots of things. And this chap, who Rob says he knows as well, Rob seems to know everybody on Everest, but I guess if you've been up there, Sandeep Dhillon, he was part of this program, BBC Doctors on Everest, and he did an aerobic capacity test at 8,000 meters on Everest. So that's the highest level to where a maximal exercise. He took an exercise bike up to South Col, which is the last 2,000 meters, last 900 meters before you get to the. I don't who carried the exercise bike. I don't know, but anyways. So, in all of that, the story of oxygen actually meets sociology, because there is a debate about science and professionalism and amateurism, and. Climbing Everest with oxygen in the 1950s simply wasn't cricket for the English gentleman amateur. And really, a lot of these climbers were English gentlemen amateurs, and there was huge debates about whether they should use it or not. But when they eventually did make it, they dampened down the newspapers and everything. They kept it quiet about how much science was actually behind that climb. And similar to Roger Bannister, not many people knew how much training he actually was doing. They thought, oh, he's the ideal amateur athlete, but actually he was an incredibly professional athlete and a scientist to do that. And even in 1968 in the Olympics in Mexico, when Pugh was asked to advise on athletes performing at altitude, and again, many people in the British Olympic Association and the International Olympic, they said, well, that's cheating if you're using science to train at this thing. People should just arrive there and do that. And the IOC really did say that this contravenes the spirit of the Olympics to be training specifically for altitude. Anyways, Pew said, well, we'll understand this. He was a pure scientist. And so things like the long jump at the Mexico Games, because of the thinness of the air, is a record, and I will show you how that record compares to the long jump now. And we also know about the civil rights in Mexico. But here is the Olympic men's long jump records going back to 1896. And there is the record of 29 feet by Bob Beeman in Mexico City. And then his record has been tied and slightly broken, but it has never been performed at that distance at any Olympics since that. And part of that has to do with the altitude, because there's less resistance in the air. But what I find really interesting, and this is really for the bar, but if you remember 1988, Ben Johnson was famous, and we were all jumping up and down in Canada until about 3 days after the race. And then after that point, the drugs testing at the Olympics become that much more vigorous. And it is quite interesting to see that the record for the long jump at the Olympics, and this takes us to 2012, has actually steadily gone down. And whether there's something in the question about surveillance of drugs is interesting. And you will see a lot of records like that in the power events. So anyways, if you look at the endurance events, however, and this is the time for the men's 10,000 meter, which we know Mo Farah a couple of years ago gave us great joy. Again, steadily coming down, performance is steadily improving, and then obviously at Mexico, the performance actually declined. This is their time. So they were much slower, obviously, because they were at altitude. And then once the next Olympics came along, they were back down at sea level, and the records have steadily climbed down. So it's a noticeable change by the altitude. And what Pew had worked out was that when you're at an altitude similar to Mexico City, it impairs your aerobic performance by about 6%. And that doesn't sound very much, but I'll tell you how much that. And he said that actually if I train you at altitude, I can improve your fitness by your performance by 3%. But that's 120 meters. A 3% off of a 5,000 meter race is a difference of 20 seconds or 120 meters. Now, here's Mo Farah. Now this is 10,000 meters, so take those guys and move them back around the track 240 meters. That's how much. If they were competing this race at altitude, they would be back around the other side of the track. And that's how much it affects performance. Oxygen meets psychology. Well, obviously this is a very bit of hairy business going on, and when you get anxious, your adrenaline starts to flow. And we even know that if you're sitting at rest, and this is an accountant, this is a junior accountant sitting at his desk at the end of the day, and his heart rate, he's got to finalize the count, his heart rate's going to 140 to 145 beats a minute, just sitting there because he's nervous doing the counts. But at a senior experienced bank clerk, his heart rate is still less than 80. So this idea of confidence and competence at what you're doing can play a big part. And if you think about the electrical system in your body, if your pulse rate is up, that means the electrical system is being highly stimulated, and that needs oxygen. And that means there's oxygen being taken away from your brain and your muscles. Now, this is a plane. This is one of Jonathan's friends flying this airplane. It's also my brother, so they're great friends. I live next door to Jonathan and become great friends, but then my brother comes along for a weekend and they become more friends, and my brother ends up working in the Antarctic as a pilot. But it's fairly treacherous flying these Canadian pilots. But they do get to go to some nice places, and this is the Twin Otter. It's Canada's contribution to the world of travel, and this is the Twin Otter, and this will be the type of plane that takes them up to Kathmandu. It's the Twin Otter, Canada's famous plane, but you can see it finds itself everywhere in the world. This is the Maldives. But nonetheless, if you're a pilot and you're not, and the work isn't that physical, that here's a pilot trying to land this airplane in dodgy weather, and on the first unsuccessful attempt to to land, his heart rate goes up to about 140. And then on a second attempt, you can see just sitting still, the amount of nervousness, if you think a normal resting heart rate's about 60, and now your heart rate's going up. And that's all nervous energy, and that all requires oxygen. And if you haven't got much oxygen to play with, then that can affect things. So really, when you're getting to this part of the journey, your oxygen supply is basically maxed out, and so there's the psychology actually can play quite a difference. So anxiety and stress do cause a demand on your oxygen. So having considered some core geography, history, physiology, and sociology and psychology, that means we've reached base camp of tonight's seminar. Now, I go on to how I started. I said I had some interesting photographs. Well, we know that Rob and Marie Kristelle, they like to play at altitude, but we also know that they like to play at sea level. And this is a photograph of them at sea level in Quebec City. So hopefully they will now entertain us. And if your French isn't very good, that means now on to our expert speakers from Everest. Thank you.
As per usual, superb, lovely overview there. A little bit worrying about how hypoxic you become. We're about to do a study where we're actually going to go with athletes in a hypoxic chamber at 16%, and I was worried about that. Merely going to base camp would probably kill me. Anyway, so we've had our entrees, we're on to our main courses now, and it's an absolute delight to invite Dr. Marie Kristelle Ross up to the podium in a minute. Marie Kristelle, I've known for under a year. She came across to the University of Chester and also the Countess of Chester Hospital, working with Sophie in cardiac rehabilitation. Really to find out about what we do in rehabilitation, but again, we've learnt loads from her as well. Marie Kristelle is a consultant cardiologist and wanted to take some of the ideas that we have in cardiac rehabilitation back to Canada, but again, we've learnt other things from her here. And I said before, she's been in my ear in my clinic telling me we do that differently. But it is wonderful to have a different viewpoint of the way you do things. In addition to being a consultant cardiologist, she also likes a little bit of sports and exercise medicine. She's recently acquired a diploma in diving medicine down in Plymouth in the southwest a few weeks ago. Is highly experienced, as you're going to hear, in high altitude climbing up to 7,000 metres, treks to Argentina, Morocco, Nepal, Tanzania and Russia. Now, I'm a consultant cardiologist, I haven't done any of that and I feel so inferior. And in addition to that, her native language is French, and she didn't actually learn to speak English until she had to chase after Rob, and then she learnt English and got him. So without further ado, I would like to hand over now to Dr. Marie Kristelle Ross.
So what I'm going to do tonight, I'm going to talk a little bit about the medical background of climbing in the mountains. Of course, it has a massive impact on the body, and I know most of you don't come from a medical background, so I'll try to keep it as simple as possible. But if you have any question, I'll be there at the end and I'll be pleased to answer them. So yeah, if you try to figure out where my accent is from, I'm from Quebec, the French part of Canada, so I live there. Going to high altitude is something quite special. If you were on an airplane, like commercial airplane, usually they fly a bit higher than the top of Mount Everest. If you're sitting on that airplane, obviously the airplane is pressurized to an altitude to about 10,000 to 2,000 meters, something like that. So if you're sitting in the airplane, you're not going to feel anything special. But if for a reason or another that airplane was to be suddenly depressurized within seconds, what would happen is that you will become hypoxic. You will lose consciousness and you will die within seconds or minutes. Yeah, people have climbed to the top of Mount Everest without oxygen and they came back. So that's just to tell you how amazing our body is, and we can adapt to high altitude. It takes time, it takes a lot of effort, but we can adapt to high altitude. And it's what I'm going to go through with you today. That picture has been taken on Camp 3 on Mount Aconcagua in Argentina. That was after we went to the summit. Had a bit of snow, it was amazing. One of the best views I've had in my life, I think. Just above the cloud, that was great. So acclimatization to high altitude, of course, is an extremely complex process. But for today, we're going to keep it simple. And we're going to talk about the lungs, the heart, and the red blood cells. This picture has been taken in Nepal last autumn. We went trekking in the Khumbu in the Everest region, and we climbed a mountain, a 6,000-meter mountain called Island Peak, and that's the final ridge to the summit. So that's our friend Diana. She was coming. She was nearly at the summit at that point. It was a gorgeous day. Really nice. So the lungs, what happened as soon as you're in an hypoxic environment, so if you don't have oxygen, and for those who don't know that, if you go high up in the mountain, if you're at base camp, the concentration of oxygen in the air is still the same. It's still about 21%. The thing is that because the pressure is a lot less, there are less particles of oxygen per volume of air. So the percentage is still the same, but the total amount of oxygen decreases. One of the first things your body does when there's not enough oxygen, it tries to breathe quicker. Okay, so that's probably one of the most important mechanisms. You start breathing a lot more quickly than you do at sea level. For example, if we're trekking, let's say we're about 5,000 meters, we get used to that, and people ask questions like, what is it like to be up there? And we get used to it. And if we're sitting doing nothing, usually I don't think about my breathing. If I were to think about it, of course it's faster than it would be at sea level. But the big difference for me is if I start doing something, if I go for a walk, I walk a little bit faster. If I want to drink something, I can't drink. I'm breathing so fast that if I try to swallow, I can't take a sip of water. I have to stop, rest a few seconds, and then I can drink. So as soon as you do something, you really notice that you're breathing a lot more quickly. Also, I'm going to be brief on that one, but when your body is under hypoxia, usually most of the blood vessels in the body are going to dilate. They're going to get bigger. But in the lungs, it's different. And in order to bring the blood at the right place, the vessel, they vasoconstrict. So the pressure in the lung increase. Therefore, the right part of the heart that has to pump the blood into the lungs has to work a lot harder. And that can become very, very important higher up because it might limit a lot of things. So John mentioned earlier that usually at sea level, the saturations are about 98, 99 if you're fine. This is 65%. And that hand is Rob's. And it was fine. That picture was taken by Rob at the South Col, which is about above 8,000 meters, and he was totally fine, but his sats were at 65%. If I see someone like that in the emergency department, I'll be extremely worried. It's almost not compatible with life. But he was there and good enough to take the picture. So that says a lot about how amazing the body is, really. The heart, that's my favorite part. When you're at high altitude, the heart rate increases. You need to deliver more oxygen to your body. So to do that, the heart has to work harder to pump more blood. Stroke volume here, the stroke volume, basically what it is, it's the quantity of blood that you can pump at each beat, okay? So the quantity of blood that comes out your heart. If that could increase, that would be great, but it's not the case at high altitude. It remains the same, and after a few days, weeks, it starts to decrease because we're dehydrated, everything is a bit different, so we can't increase the stroke volume at high altitude in general. Therefore, we really have to increase the heart rate to deliver more oxygen. This is interesting. Here you have the heart rate, and here you have the altitude. And that is the resting heart rate. So basically, the higher you go, the faster your heart beats. it varies from one person to another, obviously, but personally, when I'm around 5,000 meters, when I'm at base camp, more or less, my resting heart rate is about 100, 110. So, like, now it may be a little bit high, but usually I'm around 60. So that's a big difference, and I'm sitting there doing nothing. And if I feel my pulse, it's like, whoa, it's like I was running, but I'm just at high altitude, so my heart is trying to compensate for the lack of oxygen. Something interesting though, even though the resting heart rate increases, the maximal heart rate decreases, and that's important. Maximal heart rate is like if you were to push yourself to your limits, that's the maximum heart rate. At high altitude, it's kind of a mechanism in order to protect your heart from hypoxia. The maximal heart rate decreases. What it means is that if the resting heart rate increases and the maximal heart rate decreases, you don't have a big margin to play with regards to heartbeats. So as soon as you do something, you're at your maximal effort, as John just explained. The third thing I'm going to talk about with regards to acclimatization is the red blood cells. This is hemoglobin. This is a red blood cell, and it has the potential to carry 4 molecules of oxygen. So it makes sense that the more red blood cell you've got, the more you're going to be able to deliver oxygen. So at high altitude, one of the most important mechanisms is actually to increase the amount of red blood cells. But to do that, we have to do that via hormonal changes and everything, so it takes a bit of time. Usually, we say it takes about 10 to 14 days to see a really big increase, and it continues to increase up to 8 months if you were to stay 8 months at high altitude. And after 8 to 9 months, you have actually an increase in 50% of what you have at sea level. So when we come back from the mountains, we're full of red blood cells. That makes a big difference. That's a group. That's the first time I went to Nepal. That was in 2009. I'm there in the back. This is just to show that everyone can go to high altitude. I mean, mainly almost everyone, and almost everyone can acclimatize. And we can't predict who's going to do well. The only thing is that if you've been high up before and you did well, the chances are that if you are to go back, you're going to do well again. But besides that, whether you're male or female, old or young, we don't know who's going to do well. So the main thing is how fast you're going up. So most people are going to be able to acclimatize. What's different is just the amount of time that you need. So some people, like Rob, is extremely strong. He could go super fast to base camp, he's going to be fine. Someone else might need more time. But most people, they can do it. They can acclimatize. You just have to allow enough time for your body to do so. So even though we acclimatize, it all sounds great, but we're still quite high up. And it's not like being at sea level. We still feel the difference. And we've got better days, we've got bad days, but in general, we're a bit more fatigued. You don't have the pep that you have at sea level. You're just a bit lethargic. Of course, you're short of breath, and that's mainly as soon as you do something, you become quite breathless. It's harder to sleep. A lot of people have a bit of headache. It comes and goes, but it's often there. Also, we have a poor appetite. We're not hungry. And that's probably because there's not enough oxygen going to the guts and to the stomach, so we don't digest very well, and we just don't really feel like eating. And because of that, we tend to lose weight. And it can be quite a big problem, because if you're up there for 2 months and you start losing weight, that's not really good. And the brain as well, we're unfortunately not as sharp up there. Just a quick word about the Sherpa. The Sherpa actually is an ethnic group. They come from the east. The term Sherpa means come from east. So they came from the Tibetan plateau years ago, and they kind of migrated to the Himalayas, and they're now spread across Tibet and Nepal. They're amazing people, they really are. They're super kind, and they're extremely strong, but that's because over generations and generations, the body has had a chance to adapt. So they've got a different physiology. They've got bigger lungs, their heart is stronger as well. So they're extremely strong, and I know Rob's going to talk about them a little bit later, but I just wanted to outline how different they are to us. They've had chances to adapt over generation, and they're amazing. So just a quick word about altitude sickness, because I think it's important, if any of you has an interest in going to high altitude, you need to be aware of those things. Usually everything goes well, but it's just, you have to know that that might happen. So in 1991, a group of scientists, they went to Lake Louise in Canada, in the western part of Canada, and they kind of made that score. It's called the Lake Louise score. Basically what it is a questionnaire that can be used by anyone, and you just fill in the form, it's there. And without going through that, it's just the total score tells you whether or not you're suffering from high altitude. It is to be used with caution, but I think it's an extremely useful thing. And what it takes into account is whether or not you've got headache, gastrointestinal symptoms, fatigue, dizziness, difficulty sleeping, and of course there's a whole spectrum. You can have had a bad night, just a bit of headache, or you can have massive headache, vomiting, not sleeping at all. So it's just to be aware that it can be light or severe, but those are the things that we always look for when on an expedition. We make sure that people are fine. And also, when someone is unwell at high altitude, we have to assume that it's related to altitude. But of course, in Nepal, there's a lot of tummy bugs. You can have diarrhea because of that, not because of high altitude. You can have a virus. Also, we do a bit of cooking in the tent sometimes when it's too windy outside, so also be aware that it could be carbon monoxide poisoning. Just little things that don't assume that because you're high, it's necessarily high altitude. We have to think about that, but keep your mind open because it might well be something else. Just a very quick word about two major things that can happen. One is fluid in the lungs, the other one is fluid in the brain. Fluid in the lungs is called pulmonary edema. Okay? Because when you're hypoxic, the blood vessel in your lungs, they become more permeable, basically. So water can diffuse from your blood vessel into the lungs. And when there's there's water into the lungs, you're feeling short of breath. And actually, it can be quite dangerous. It's not often that it happens, but it's not that rare either. And we've seen it higher up, and it can be quite serious. And only 50% of the cases are preceded by acute mountain sickness. So someone can be quite well one day and the next day very unwell with pulmonary edema. So that's something we need to think about. And if someone is sick at high altitude, the treatment is very simple, actually. You give oxygen and you go down. That's the only thing that's really going to help. We've got medications, we've got a bit of studies and stuff, and of course we're going to give them as well. But I think what's really important to know is that if someone is unwell, you give oxygen and you do everything you can to go down. That's what's going to save them. Same thing with cerebral edema. So cerebral edema, what happens is that there might be a bit of swelling in the brain, but because your skull is bone is fixed, the pressure will increase, because if the brain swells against something that's fixed, you're going to have headache, and it can lead to coma and eventually death. Again, simple, if that happens, you need to give oxygen, you need to go down. That's the only thing that's really going to save that person's life. We've got fairly good data as well about corticosteroid dexamethasone, but again, you go down and give oxygen. That's what I want you to remember. I don't know if you've heard or not about the Gamel bag, but it's something that can be used if available. So basically what it is, it's a recompression bag. So you put someone inside the bag, you zip it, you pump it, you increase the pressure within the bag. And it's like if you were bringing the person down, the pressure increases. It's not like you're bringing them to sea level, it's not that good, but it might give you the time to act and for your medication to be useful. What's more important from my point of view is to prevent that from happening, and most of the time we can prevent it, so that's a good thing. In general, as a rule of thumb, what we say is that you have to go up slowly. In general, we say about 300 meters per day per 24 hour, and every 3 or 4 days you should take a rest day. So that allows sufficient time for your body to acclimatize properly to high altitude. If you tend to go quicker than that, And it's what we see with people who are relatively young and fit. They want to go fast, they want to get there, but actually they're the one who get into trouble because they're going so fast that they don't have time for the red blood cells to produce and everything. So you have to go slow. It's also very important to be well hydrated and to have a sufficient calorific intake, because as I mentioned, the appetite is not very good. So if you keep losing weight up the mountain, you're not going to get any stronger. One thing that's important as well is that if you're not well, you don't go any higher. You have to either stay there, or if you're worried or if something is wrong, you go down. So if you're not well, don't go higher. That's basic, but it's often forgotten. So that's very important. And just a quick word about acetazolamide, because I've been asked a lot of questions about that. It's called Diamox as well. And it's a drug that, it's a diuretic, and it's used for the treatment of acute mountain sickness, but as well for the prevention. And we've had a few studies, like 100, 200 patients, but nothing very strong. However, in 2012, Mike Gruckett from Southampton did a meta-analysis of all those studies of like 1,500 patients. And it's been shown that Diamox, when taken in prevention, decreases the incidence of acute mountain sickness. Therefore, we now recommend for people who don't have any experience and are going trekking above 3,000, 3,500 meters to take Diamox twice a day in order to prevent acute mountain sickness. And basically how it works is that is along here is CO2. So when, as I mentioned, when you go high, you breathe a lot faster. Therefore, you excrete a lot of CO2. That makes your blood more alkalotic. And the body is clever enough that when the blood is too alkalotic, it says, okay, don't breathe any quicker because we're going to pass out, it's not going to work. So your brain tells you to stop breathing that fast. What Diamox does is that it helps you to excrete bicarbonates. Okay, so it's a diuretic. Therefore, you urinate more and you urinate bicarbonates. What it does is that when you urinate that, it brings your blood closer to a normal pH. Therefore, you can start the process all over again. Okay, so it allows you to breathe more, basically, is what it does. And in summary, it's an amazing place. The body is amazing as well. And over time, if you give him the chance, it will adapt to high altitude. And you're going to enjoy your stay there. It's not, even though we talk about headache, breathlessness and everything, it's not as bad as it sounds. And once you're there, you quite enjoy it. Altitude sickness, it's important to be aware of it, but fortunately, most of the time we can prevent it. So just keep that in mind as well. And thank you, and I'll let Rob talk a bit more about Everest and his experience up there.
What a wonderful talk. A little bit frightening. I mean, how many people here have thought that they might, before tonight, go up Everest? No, before tonight. There's nobody now, though. I mean, it's just dreadful, isn't it? I mean, I thought about it later this year. Absolutely no way. So, on to our final speaker tonight, and it's an absolute pleasure to introduce Dr. Rob Casserley. I've known Rob now for at least 3 weeks, and I wish I'd known you sooner. He wished less. Rob initially was a surgeon, then became a GP with this interest in going up mountains, altitudes, expeditions, had his own company. He's been up Everest 8 times, which makes him really mad, including a double summit in spring of 2007 and spring 2010, which is the first Westerner to have achieved this. He's featured in that Everest ER documentary and has assisted Sir Ranulph Fiennes, who he calls Ran, and has been all around the world. Some striking things he's done: 10 marathons, fair enough. Then he rode across the Atlantic, and at the end of that he was bored, so he flew to Nepal and went back up Everest. He gives lots of inspirational, motivational talks as well, and you'll see why in a moment. he also has learnt a new language. Marie was learning English to chase after him. He was learning French to get away from her. But unfortunately, they did meet up and get married. But it is a real pleasure to welcome Dr. Rob Casserley to the podium tonight. Thank you.
Does everyone want to stand up and just stretch the legs, get the oxygen to the vital organs? Come on. Shake it around, everyone. Bit of a stretch. I was at circuit training this morning at 6:45. I'm now regretting it. Anyway, thank you to the previous three speakers and John for chairing the evening. I've learnt a lot and hopefully it stimulated some interest in the audience tonight. They say very nice things about me, so if I've ever been set up to fail, that's definitely the prelude to it. Anyway, hopefully I won't disappoint. I'm going to try and take you up to the summit of Everest and make you all want to do it, or certainly give you an idea of how to do it. I'm one of the lucky ones. I've managed to forge a hobby and make it my career. So I'm a GP. Yes, I know you can't get an appointment for 1 or 2 weeks to see your own GP. That's because we're all climbing mountains or off enjoying ourselves. So climbing as well as being a GP. So I'm extremely lucky. So why did I want to climb Everest? Well, like a lot of young lads and probably young ladies as well, I kind of toyed with the idea of being a fighter pilot. But my rendition of "You've Lost That Loving Feeling," aka Tom Cruise, "You're Inverted," didn't quite cut the mustard at singing practice. I thought about being a stuntman, but I have all the acrobatic capability of a legless dodo, so that wasn't going to go any further. We all kind of wanted to be on the moon at some point, but NASA didn't even take a second look at me. And I kind of toyed with the idea of climbing Everest, and for me, this picture is one of those iconic images up there with probably the video footage of JFK being assassinated, the first lunar landing, Apollo, crumbs, is it 9 or 11? Or 10? What is it, 11? 11, thank you. So for me, that's one of those iconic images. So Sherpa Tenzing with Sir Edmund Hillary, who took that photograph on the 29th of May, 1953. An amazing feat in history. So climbing climbing Everest in particular has led me into meeting some really interesting people, as varied as Sir Ranulph Fiennes, or Ran as I say apparently. And although in 2008 we didn't get to the summit with Ran, we actually did something a lot more important, and that was to raise £4 million for Marie Curie. He'd lost his wife from cancer some years prior to that. And so he's obviously a dedicated individual, and he went on the following year to summit, which is all the more effort, and congratulations to him. It's also led me to meet incredibly spiritual and humbling people like Lama Geshe and Pangboche. Pangboche is a small village in the Khumbu Valley. It's where most of our climbing Sherpas come from on our expeditions. And this man is one of the most incredible people that I've met. And he's a sort of person I like to carry with me wherever I go, certainly into places of deep danger. So here on the summit of Everest a couple of years back, I'm there with Lama Geshe, and I'm sure he's keeping me safe. Well, that's what I'm believing at that moment in time. People often ask me, why do you keep going back? And I say to them, why do you keep going to work at the same place? Because most of us, have to do these things. I would say to you that going to the Everest region is incredibly empowering, both from a geographical perspective. You see the most amazing mountains in the world. You see some incredible and participate in the most incredible culture and religion. So Buddhism. I think if we all took the aspects of Buddhism, which is effectively doing to others as you would like to be done to yourself, taking the middle path, not being extreme. If we all took some of the lessons in Buddhism with us, I think there'd be a lot less conflict and hassle in our day-to-day living. And also you make some great friends. Some of the best friends I have now have been met through my contacts in climbing and my experiences in the high altitude. So it does, when you keep going back, make you realise that sometimes you might be biting off more than you can chew. So this is just above Namche Bazaar, the first site we really get of Everest. So I'm standing at about 3,500 metres. The mountains are 8,850 metres. I'd like to correct the surveyor. The 8,850 or 29,035 feet is the new accredited altitude. Well, that's what I'm going to claim. It is growing by a couple of centimetres every year, so that's perhaps the discrepancy. But it's still 5 vertical kilometres higher than me at this point. So that's Everest. Everyone thinks it's Lhotse, the 4th highest mountain in the world. I've been fairly high on Lhotse to about that point when my crampon snapped off. A little adage, a life lesson I learned at that point when speaking to the expedition leader was, Henry, should I carry on? And he said, Rob, better to be a live lamb than a dead lion. And so I've taken that little saying with me to defend my cowardice wherever I can. You also get to acknowledge that many people have died climbing Everest. So although it's becoming increasingly safe to climb the mountain, there is still inherent risk in doing so. And on this, the memorial there that you saw, the Everest Memorial in Ferrochet, is the name of one of my teammates who died on the 5th of June 2005, Rob Milne. In a somewhat kind of amazing illusion, he's the inverse of Sherpa Tenzing, and how obviously different their fates were, a summit and a near summit and death. He collapsed on summit night, and it was obviously a terrible night for us all, and ended our brief foray that night. So 8 summits and 1 near miss. The final thing that makes you realise that this is a serious place are the memorials that you see on Dougal Hill leading into Lobochet, one of the other villages near base camp. And these are memorials to climbers, untold numbers, who've lost their lives on the mountain. But on a brighter note, when you get to base camp or near base camp, you're rewarded with an amazing view. And you can start picking out some of the route. And if you look very closely, you can see a kind of divot, like someone's taken a golf club to this part of the mountain. And that's the south summit, what everyone thought was the true summit from the surveys that are done to assess the route pre-1952, the Swiss, and then the fateful and successful 53 British expedition. And what you find when you get to the south summit is that you're actually nowhere near the true summit. You've still got another 400 to 600 metres horizontally and another 100 metres vertically to get there. This is Nuptse, and from surveying we can see that it looks bigger, but in fact it's in the foreground and actually is 1,000 metres or almost 1,000 metres lower than Everest, despite that appearance from this position. So the route, we start at base camp, and we've all heard how awful it is at base camp. In fact, it's pretty easy going. We spend a lot of time there. It's very relaxed and chilled. There are tables and chairs. We have heaters. We have quite a good life. We've even got videos now and DVDs at base camp. But actually, the quintessential basis for enjoying the experience of expeditioning is that you spend time with people. You get to sit around a table and eat dinner together. You're not rushed from pillar to post, picking up the kids or getting to work in the morning. You can just enjoy the place and the company of others. Anyway, we start at base camp, we go through the icefall. This is the most dangerous part of the climb. Probably more people have lost their lives in that part of the ascent on Everest than anywhere else on the mountain. It's the Western Combe, which is a glacier that collects snow runoff, which compresses and forms a glacier or ice from Lhotse, Nuptse and Everest. And as you can see, it's a horseshoe of mountains. And it really is a fantastic thing to see in real life. We go to Camp 2 at 6,400 metres, up the Lhotse face, a quick left across the Geneva Spur, to the South Col, and Bob's your uncle, you're on the summit before you know it. It's a bit easier here, but it takes almost 2 months, and Mary, Kristelle and myself will be leaving on the 5th of April, and our return flight's currently at the 31st of May, so that's a sort of time commitment you need to give if you want to climb. People say, man has made a huge impact on the landscape, and there's a big thing about rubbish on Everest, and there certainly is the ill effects of human beings on the mountain, but it's an incredibly large place, and if you look very closely you can see the tiny nature of what base camp actually is. When you're there, it is like a living city. It's a vibrant atmosphere. There's lots of different nationalities. There's yaks coming in and out, supplying us with the logistics. But at the end of the day, we're very, very small compared to a very large area, and this is just leg one of the climb. Before you embark on the icefall, like I said, the most dangerous part of the climb, I think 100% of Western climbers will take the added benefit of a blessing, a Buddhist blessing, or the puja. To me, this is really important. We're actually in their backyard, and it's for us to sort of follow some of their rituals and customs. And actually, for me, it's a deeply spiritual place, as I said. And this is the Lama chanting. We're raising prayer flags, and on these prayer flags are sort of scripture, Tibetan scripture. And as the wind blows through these flags, which are fluttering in the wind, it's thought to bring good fortune upon us and request to the gods to let us have safe passage. And actually, the flags fluttering in the in the Himalayas is one of those quintessential noises that you never forget once you've been. You get some amazing shots from base camp. This is the Ranfines year, but Mountain Hardware were kindly supporting us. This is taken in the middle of the night. You can just catch the stars. So I was using a new Olympus camera. Being the chief photographer and physician to surround our finds meant I had to learn a bit about delayed flashes and delayed exposure. So now I can take a reasonable photo with the help of a very expensive camera. And then you see some crazy things like horizontal rainbows. You can just see the near summit of Lhotse. This is the west shoulder of Everest and Nuptse. So, the icefall, up close and personal. The blocks of ice are massive. They can be the size of a house. And you can see here, this is Kenton Cool, the most summited Brit there is. He's summited Everest 11 times now, just making his way through these obstacles of ice. We need to use ladders. You can see here they've been shackled together with rope. They do have sort of guide lines to make them a bit more stable, but it's not much fun going up a 5 vertical ladder section. Each ladder is, I think, 20 feet or 6 meters, so it's a long, long distance that you're going up or across. The ladders can be horizontal. So let's see what it's like to cross a ladder real time. It's a long way down. Right down on the old arm. It's not exactly action, is it? Step by step. And here we go. And that's how you cross a crevasse and the Khumbu Icefall. So going to what John was saying, it's actually quite stressful. So you can hear my breathing rate's pretty elevated at that point, and I'm sure it's just down to stress. Anyway, when you get to the top of the Khumbu Icefall, you're rewarded with amazing views, and this is Camp 1 in 2007. This was the Extreme Everest expedition that was being referred to a number of times, a huge ITU and anaesthetist study into human physiology in hypoxic conditions. But the logistics that they had to get things like bikes, exercise bikes, to the South Pole, 8,000 metres, was just phenomenal. You can see the routes that we take. This is the Lhotse face. The summit attempt on Lhotse takes you up the Lhotse couloir. But we come up here, Camp 3 at 7,300 metres. Is somewhere in this bergschrund. We then cross what's called the Yellow Band, a geological feature, and then up the Geneva Spur, and then to the South Col. From Camp 1, it's a fairly slow meander, and this probably gives rise to what armchair critics will say, well, Everest is pretty straightforward, and I would agree. It's certainly not the most technical climb there is, but that's part of its charm. It allows people with other facets, other credible characteristics to give them a chance to climb a mountain that was up until only 20 years ago essentially unattainable for the average punter. But we take a long steady walk effectively from above the Camp 1 to Camp 2, nestled at 6,400 metres or 21,000 feet. When you're at Camp 2, there's a predictable precipitation that comes in, or cloud cover, towards the end of each day. And you'll see, if you look at satellite images of the Khumbu Valley in the morning, it's nice and clear. And then every day the cloud comes up from the warmer, moister valley lower down to the higher reaches higher up the valley. The secret of success. It's fairly obvious that going to 8,848 or 50 metres is going to lead you into profound hypoxia. And that's not really compatible with, certainly not compatible with human survivability, and it's certainly not compatible with performance. So oxygen is used, and this kind of leads me into one of the most important aspects of climbing Everest. It's the Sherpas. Those oxygen cylinders aren't just miraculously teleported there. Someone has to get them there, and it's not a Western climber. it's hard-working Sherpas who are just boys from the village who've kind of signed up. They do now have a system where they actually get climbing skills, but a number of these guys, they're not Sherpas, they're actually Rai or some other caste that has no real selective advantage at altitude. But they've got involved in an expedition and they're walking on those ladders just like us with no real experience. Thankfully, that's changing more and more, and sort of safety techniques are impressed upon them more and more. But these guys are gold. This is Tundu, one of my best Sherpa friends. We sort of run a trekking company together now, but they're carrying huge weights. I'll carry maybe 20 kilos going up to the South Col. Tundu and the guys, they'll carry almost 35 kilos, sometimes 40 in their kind of logistical onslaught of climbing Mount Everest. And it's all for our recreation at the end of the day. They're incredible companions. You'll notice one Western climber, one Sherpa, one Western climber, one Sherpa. Always like a good scuba diver, you'll buddy up. And so Sherpas are there on summit day 1-to-1. And basically good expeditions will always have that ratio. The expeditions that get into trouble are the ones where they have less logistics, less Sherpas, and as a result, when the proverbial shit hits the fan, there isn't anyone else to bail you out. I go now as a guide, I'm there overseeing other people, but at the end of the day, does a Western guide stack up to a Sherpa? Absolutely not. I'd have a Sherpa any day of the week compared to a Western guide. And they're doing crazy stuff at really high altitude. This is Ward, a friend from California, and here's, I think it's Padawa, a good Sherpa friend. He's just changing the cylinder for Ward. We become kind of helpless, marooned, unable to really do any kind of fine motor task. And these guys are just behaving normally. They're functioning at a high level. So they're really our angels. They're really looking over us whenever and wherever we are on the mountain. So the Lhotse face, like I said, you can see Camp 3 here at 7,300 meters. It's a fairly formidable thing to look at face on. It's about 1,000 meters. So you're at the base here, it's about 6,700 meters. The South Col is just under 8,000 meters, so you've got 1,300 meters of ascent up a sometimes sheer blue ice face. So this is 2005, it's a dry season. The problems as well with dry seasons are that there are rocks coming down from Lhotse. And so when there's no snow sticking all these rocks down together, you actually get significant rockfall. In 2007, Kenton found a Sherpa effectively with no head because a rock had come down 1,300 meters and hit this guy directly on the head. We all now wear helmets. You'd think that's pretty obvious, isn't it? And actually, prior to 2007, we weren't really wearing helmets going up the Lhotse face. We didn't really perceive that to be a risk. So I guess we can be trained, even the experienced older dogs on the mountain. To give you a sense of scale, you can see the climbers clearly in the foreground, just here. If I pull out, you'll see they suddenly become very, very small in the scheme of things. And that's the lesson in life, I guess, on Everest. We are but very small things in this wonderful planet of ours. When you get to Camp 3, it's not a place to hang about, it's not a place to relax, because if you get out of your tent without your crampons on, you're going down much more quickly than the way you came up. So it's a sort of place that if you need to get out of your tent to relieve yourself, you put your crampons on. There are guidelines between each tent, so you try and clip on, so that you're not freely walking on a face that will lead to a 1,000-meter drop if you just clip your heel and make a mistake. The view from Camp 3 is amazing. And a lot of the climbing psychology, and we've heard how important that is with your oxygen demand. This is Cheoyu, the 6th highest mountain, and a lot of the climbing psychology in recent years has been that to climb another 8,000-meter mountain before Everest, so that it gives you a kind of psychological bolster, a strength, to know that you're capable above 26,000 feet, and as John Krakauer coined it, the death zone. So when you look at that from Camp 3, knowing that you've been on the summit, and I've been luckily to the summit of Cheoyu twice, I knew when I first went to Everest in 2003 that actually I had a really good chance, and it's amazing the comfort you get from being psychologically strong. So as you leave Camp 3 on your departure, you're actually leaving for your summit night the moment you step out of the tent at Camp 3. And in fact, really, your summit night is starting the night before that night in Camp 3. You sleep badly, You don't sleep very well because the tents have been there for a few weeks. The sun actually on the face is brutal, so the bottoms of the tents melt out. So a 3-man tent suddenly becomes the space of perhaps 1.5 people, yet 2 or 3 people need to share that space. You're not flat, you're curled up in little balls, you've got very little oxygen to breathe with, no one's really eating or drinking that much. And part of my job is to motivate people to counter some of these difficulties and project forwards and ignore those kind of physical feelings and psychological dreads, and to replenish and to motivate themselves to leave the tent the next morning. So here we go up. We've got the yellow band in view. Now this is what you should never ever see on Everest. And at this point, I should have realised we shouldn't proceed. This is 2012. The next day, 4 people died. It's the last time I summited on Everest, and hopefully in 2014 it's going to be very different. But when you start cramming a number of people into a short window of opportunity, and then you push the season back and the weather isn't being clement to you, suddenly people get fidgety to leave base camp. But clearly this is not how it should be. We're on ropes that should accommodate maybe 3 or 4 people for every 40 to 50 metre pitch. So these ropes are anchored in ice, and every 40 or 50 metres you'll have another anchor. So you're clipped to this rope, and you should be able to freely move on this rope. You couldn't pass anyone on this line. And there were well over 200 people on that summit day. It is the best estimate. 4 of them didn't come back. That's how it should be. That was just our team. And we had a couple of other people there. I think they were the Sherpas. This is 2005. We were the only trip that went that night. So this is the day before our summit push. Again, you see the contrast to 2012. So this is where some of the bad press from Everest rightly comes. And it's something that we really need to do better at base camp. But still, the old habits, prevail. Retaining information, some bigger expeditions paying for good weather forecasting, knowing when the best opportunity is to go, and then not sharing their movements with other people, and therefore, by chance, you end up with lots of people all going at the same time. So hopefully those kind of obstacles to a safe and a successful summit are being broken with a newer generation of climber who's more willing to share and communicate. Communication is or lack of communication is the root of most failures in the National Health Service, and I think it probably in most professional walks of life, if you've got good communication, you'll probably avert significant disaster most of the time. Anyway, the Geneva Spur, coined by the Swiss, they almost summited Everest in 1952. In fact, they probably should have carried on to the summit. You can just see the summit poking out there, or you think it's the summit, but that's actually the south summit. Anyway, so we take this long traverse. It goes on and on and on. You can see all the people from 2012 following us up. And then you get to the top of the Geneva Spur, coming into the South Col, and your first view of Chomolungma, Goddess Chomolungma, the highest mountain in the world, or Everest, after Sir George. The route we take starts kind of on this whiteboard here at the South Col. We come up the right-hand finger of these 2 gullies. We go through a mixed rock and ice band, and we go to the balcony. The balcony sounds amazing with deck chairs and ice cream vendors, and sadly it's not like that, and you'll see a photo of that in a moment. That's when we hit the ridge, the southeast ridge, up to the south summit, and then the final push onto the peak. So, what's it like in real time?
Absolutely stunning.
Ah, there
Down
you go.
there is Camp 2, 6,350 metres, a whole vertical mile down. It's hard to believe that we came from there only yesterday. Wow.
I had to think about that.
Anyway, well, I guess the money shot, if it still hasn't clouded over too much, is that. Wow. Summit Pyramid of Everest.
You focus up here.
I mean, it's unbelievable. We're going to zoom in, attemptingly, very slowly. And what you can see there is a person coming down from the summit. Isn't that amazing?
So unlike me to correct myself, I actually mean the south summit. It's not the summit. So that was the full
The
summit.
South Col is in the general direction over there.
So again, I freely accept it's not the hardest mountain in the world, but it does pose a significant obstacle and certainly a number of psychological hazards and physical hazards before you can just waltz your way to the summit. So there isn't a yellow brick road, that's for sure. Anyway, coming into the South Col, it's a nice wide open camp. It's much nicer than Camp 3, so you can get out and walk around. At least the sort of stunning views. But here you get Chinese cell signals as well as Nepali cell phone signal or mobile. I've been in Canada for a few years. I'm now saying cell phone. Mobile phone signal. You're on the frontier of two countries, Nepal and Tibet. Your head doesn't blow off when you're not wearing oxygen. So it's 26,000 feet. My oxygen saturations at rest in a tent are 65%. You feel fine, or I guess I'm slightly freaky in that although I don't necessarily look like the most physically able person, at altitude I do pretty well. And I guess if there was an altitude Olympics, I'd be up there. But sadly, the Olympics aren't at 8,000 metres. So you can be quite functional. This is the trip with Sir Ranulph Fiennes. We were at the time doing the highest live broadcast with ITN. So that's a satellite. So BGAN satellite, we had a flash drive computer, so that worked at that altitude, videoing, and so I was filming Ran and Kenton live for ITN. So it's quite cool the opportunities that have come my way just by, I guess, being in the right place at the right time. So going back to the source of success, oxygen. These are the old masks we used to use. This is an old MiG fighter pilot mask from the 50s. Poisk, a Russian company that manufacture oxygen bottles, and they're the bottles that we use on the mountain, and they hook up to these MiG fighter pilot masks. But they were really cumbersome. They almost covered your vision, or they significantly hampered your vision. Plus they came out a long way, maybe about 15 to 20 centimetres beyond your face. So they certainly didn't help you see your feet. So another hindrance to a safe and successful summit. Most people don't appreciate that we set off at night time. So we go in the dark and we come down, hopefully, in light. Often before we set off, it's really, really windy. And a lot of people, certainly those with little experience, are quite concerned about getting out of the tent in high wind. But whenever you're in a tent, it always sounds a lot worse when you're in it than when you're out. But it certainly does take a lot to motivate some people to get going. Although it's slightly out of coordination in terms of time of the day, this is the balcony. So pushing up out of the South Col to get to the balcony, this is it. This is where we change oxygen cylinders for the first time on summit night. Or I should say the Sherpas change oxygen cylinders for the climbing members. And then we push on. And it's probably a good reason that we do this in dark for first timers. Now we've just started on the southeast ridge. And the reason why it's good not to know what's lurking the other side is this. Now, it takes a little while to work it out, but this is the Kanchung face, and this is 10,000 feet in vertical descent, so about 3,000 metres. You can see the horizontal with the cloud cover here. You're not going to stop yourself with an ice axe arrest going down there. Luckily for idiots like me, there are ropes set up by friendly Sherpas a few days before, which allow the less skilled climber to use a Juma or an ascending device to follow the rope, and that's, I guess, where the yellow brick road accusation about Everest comes from, but to follow the rope safely up. The people who go wrong are the ones who either get their fixing of the ascender or their safety carabiner. They often clip into thin air, they don't clip in, and they think they've clipped in, and sadly when they come down to an anchor thinking they're going to stop, they carry on unexpectedly, and that's, I'm sure, happened a number of times. So this is Tim and Padar. This is Summit in 2006. We were the only team on the mountain. 5 members, 5 Sherpas. It was absolutely awesome. Nothing like 2012. You see amazing things. It's the Tibetan Plateau looking out east. When you see the sun, it's an amazing psychological boost. Daylight, with that comes hope, warmth, or a bit more warmth than what you've been going through that night. You carry on inching up. You look down at the balcony. You see how exposed it is. The South Col's down here. You've come quite a long way. You look back at Lhotse, the 4th highest mountain. My crampon came off just there. You start off just down here by what we call it looks like a turtle, apparently. But Camp 4 of Lhotse is just there, and you come all the way up here. And it came off there. Remember, better to be a live lamb than a dead lion. It allows you to speak in Chester to hopefully a friendly audience. And the view from Lhotse of Everest, to give you another perspective on the route we take. So this is me with a throwaway camera on Lhotse. The right hand of those gullies, up to the balcony, up to the south summit. And here you can really see that golf club divot taken out between the south summit and the true summit. And actually this poses probably the biggest hazard on summit night for us. On summit day, there's a significant steep mixed rock and ice section, which can be extremely demanding. So that's the wind, not a jet exhaust. Probably one of the most stunning mountains in the world, Makalu, the 5th highest mountain in the world. Kanchenjunga, the 3rd highest mountain in the world. Lhotse, the 4th highest mountain in the world. You're on the highest mountain in the world. This is Amadablam, one of the very iconic mountains that people who have a climbing interest will know about. It looks very, very small from 8,700 meters. And in that time, the sun has come up. Anna, one of my teammates, is pretty happy there. You can see the sun coming up. And that's the Kanchung face. Moving swiftly on. Mark II of the oxygen mask, it's changed a lot. It's now much more flush, it forms a better seal, it's more airtight. So men who grow beards are certainly a disadvantage because it's less good seal. We actually now have a working cylinder, so there's a bottle hanging down here like the size of a Coke can, an old Coca-Cola can. And basically oxygen's flowing from the oxygen cylinder at a rate of maybe 2 litres per minute. When we're breathing in, we're using much more oxygen than that, but there's no doubt that when we're breathing, when we're breathing, inspiration takes normally 1/3 of the time of the respiratory cycle. Expiration is about 2/3 of the respiratory cycle. That will close up when you're breathing very rapidly, but nonetheless, at least half of the time of breathing is spent blowing out, so not using the oxygen that you're being supplied with. So with the old mask, there was no reservoir system, and the oxygen would just flow across the mask. So when you're half the time, you weren't using what you were carrying on your back. With this system, oxygen, a little bag was inflating, and although we were still breathing many more times the volume of oxygen being supplied, it gave you that extra pep. And so climbing times to the summit have started coming down. And people are now starting to arrive at the summit at 2 or 3 in the morning, which is a bit of a shocker to go all that way on a lovely clear day and end up there in the middle of the night. So we're now finding that we have to juggle the safety of getting people up and down, ideally down in daylight, but leaving it too late because we expect them to get to the summit much more quickly. It's a difficult juggling act. I've seen some amazing things near the summit. This is a shadow of the summit cast onto the skyline. I think this is called a Brocken spectre, although someone very clever at a previous discussion about this photo said it wasn't a Brocken spectre. I don't know what it is, but it's pretty amazing when you see it. I even took some video footage, but Mary Kristelle made me exclude that from this talk because it would be just watching a shadow. Moving swiftly on, hopefully. Battery must have run out. Oh, hello. I think there's a little hamster in the computer. Okay, well something's we're back on the road. That's great. Anyway, so here we are at the South Summit. So here we are at the South Summit, 8,750 meters, and this is where the final push. This is what caught out Tom Bordelon and Evans in '53. They could have been the first guys on the summit, and they were here about 3 or 4 days before Hillary and Tenzing, and it was with their reconnaissance and their probably very good decision, better to be a live lamb than a dead lion, they decided when they got here late in the afternoon that it was better to come down. And as a result of them finding out that this was the South Summit, they passed on the information to Hillary and Tenzing, and they actually moved their last camp up to near the balcony. So they went up an extra 400 to 500 meters. So they actually had a very short summit day. So it gave them much more time to tackle this problem. And this is the step, the Hillary step, coined after that first ascent. But for me, it's actually getting to the Hillary step with a Remember, this is 8,850 metres. This goes directly down to Camp 2 at 6,400 metres. So it's a drop of 2,450 metres. So it's a long way, almost 8,000 feet. And then on this side, you've got the Kanching face and a 10,000 foot drop into Tibet. So it's very much focusing of the mind when you're up at that kind of place. Get a bit closer to the Hillary Step, and what's it like up close and personal? It's actually changed from this. Now there are fixed lines that get cut away each year, and a new one is fixed. That's part of commercial climbing, I suppose. But this is just a few years back, where you'd see a cobweb of ropes, and you wouldn't necessarily know which was the line that had been fixed that season. So the policy really was to attach your Jumar to the most likely looking one, grab a whole bundle of the others, and then take a punt and go for it. And it wasn't much better coming down. So now we just have one rope. Sometimes there are two ropes, so people expect you to try and descend down a line here and another rope here, sort of an ascending rope. It never really works like that. Most people go up and down the same rope because you don't want to be hanging over a 2,500 metre drop. 2012 it ended up coming to that for us to get down. So this really will affect people with vertigo. So I'm just at the base of the Hillary Step. I'm looking down at Camp 2. It's not vertical, but it's not far off it. This is Nupsi, about 1,000 metres lower. There's Amadablam. And back to the yellow brick road. It's not very wide, and it's a long way down. And this rope is about the width of my little finger. These aren't ropes designed to break or fall. They're more of a psychological guidance to kind of lead you down. And now we're just looking over the edge down the Kanching face. Anyway, so before going up the Hillary Step, you take a look left or west. You can see Choyu, the 6th highest mountain in the world. I've been up that, so I can carry on going. You look at Shishapangma, the 14th highest mountain in the world. You look east, you can see Makalu, the 5th highest mountain in the world, as I said. Kanchenjunga somewhere out there. Oh, computer's gone again. You look down at the Western Coombe and base camp. Base camp seems like a terribly long way away at this point in time. You look back up to where you're going, and you have a punt, like I said. And this is me on the Hillary Step, and doing all right. So when you're at the top of the Hillary Step, what do you see?
This is Ward on the Hillary Step. Give you an idea of the exposure. See Tibet.
It's a good job we're in the geography department, I think.
Well done, mate. Keep coming.
So you can see how slow he's moving at this altitude.
Lots of old ropes from previous expeditions. You can hope you got the right one. Grab onto a whole bundle.
So Ward is this very cool Californian.
Well done, Ward. Excellent.
He didn't want some chippy Englishman
Okay,
saying
say goodbye
the
now.
rope was likely going to
Thank you,
break
guys.
with him pulling up, but he took it pretty well. So we're almost at the summit. So if you get it right, you can get a blue sky day, little wind. Remember, you've got recreational climbers under your duty of care, I suppose. So you really want to try and get to the summit and get your people up on a day like this. This is my first summit in 2003, taken with a throwaway camera, and it's amazing how technology's moved on, that we're using digital cameras and taking loads of photos. But this was a deeply unpleasant day. It took 21 hours to get up and down safely back to the South Col. My Nalgene water bottles, which I thought would be better off in an insulated container inside my down jacket, froze. So I couldn't drink anything, I couldn't eat anything because my gels had frozen in my top pockets. And the things you learn from experience. It was utterly brutal. But like I said, if you get it right, you can have the most gorgeous of summit days. This is 2010. The interesting thing about this lady here, Anita, she had a respiratory rest at Camp 2, only about 12 hours later. So we started at Camp 3 the night before. We went to we arrived at the South Col that afternoon, having woken up very early in the morning. So we'd gone from 7,300 to 8,000 meters. We left that evening, climbed overnight. We're just about to get to the summit. We got back down to the South Col by 12 o'clock the same day, so noon. And then we descended to Camp 2, where she, over a period of hours, much to her husband's dismay and disbelief, he thought she was having an anxiety attack, she lost her airway. And what we find, or certainly what I should write up case studies. I'm not a published medical researcher, sadly. These are the great people who have spoken before, who've got the brains to do that kind of thing. But I've seen a lot of stuff, and people's airway they narrows and they get tracheitis because the air that we breathe in is really cold, it's really dry, it's intensely inflammatory, and you get a very telltale sign, this high-pitched squealing cough. Voice goes a bit kind of laryngitic, hoarse voice. And she literally, I saw her stop breathing. And everyone looks at you. It's Camp 2. It's about 10 o'clock at night. You're absolutely shattered. And someone who's 39 years of age has just stopped breathing and is looking at you in the eye. And it's a fairly horrific experience. And I didn't have a clue what was going on as it happens. She'd just stopped breathing. But just by moving, doing some CPR, giving her some dexamethasone, giving her oxygen, probably was making it worse, actually. But just doing a lot of things and probably moving led to this huge cast of her trachea coming up and out of her mouth, and it secured her airway once again. But it was a pretty scary, harrowing episode, I can tell you. But that's kind of real medicine, and it's kind of a different type of medicine to what I do day to day in general practice, for sure. So there's loads of rubbish on the summit of Everest. No, there is not. These are prayer flags, and they are taken up by the Sherpas, who are deeply spiritual, and they revere this mountain. This is a sacred mountain. There are, I admit, some oxygen cylinders that get left, but the Sherpas are now incentivized by $50 per bottle to bring it down with them. So actually the summit is pretty pristine at the end of each trip, other than these prayer flags. There will be meters and meters in terms of depth of decomposing, or probably not decomposing because nothing really decomposes this high, but layers of prayer flags that are frozen in to the mountain. But I'm okay with that. So from the summit, it's a long way down. You've got a great view, and if you look carefully, this is not photographic distortion, this is the curvature of the Earth, which you can clearly see, and this is just a normal 35mm digital camera. So an elating experience. I like to claim, that I'm some superhuman because everyone else is wearing their masks, but in fact, you just take it off for the photograph. I'll do you a quick 360 on the summit. Only reason being, people ask, how big is the summit? So you'll see here, this is actually a Perspex Buddha. Inside there is a case, and inside that is a Buddha that someone brought up from the Tibetan side. So I'm now getting tangled in prayer flags as I kind of rotate around and almost fall off the summit in my kind of hope to give you guys a nice 360. This is the mushroom. They talk about this on the north side. So they're coming up from the northeast ridge. So it's a great moment when you see people coming up from here to meet you on the summit. We're spinning around. I remember they called for a lot of cloud cover, so that's deeply depressing when you're trying to get nice shots from the summit. But thankfully the cloud was really low at 6,000. Kanchenjunga, Makalu, we know that very well. You can see it looks fairly precipitous, this fall just there. At this moment in time, I should add, I was on the summit all by myself. I had it there half an hour and just admiring the most amazing view. Lotse, your teammates coming up. I wish I had a fast forward. Sorry about this. There's Amadablam, an absolutely stunning mountain. And what I'm going to try and do in a second is to give you an idea of how big the summit is. And it's from about here to the end of that table. And it's no wider than this table. And if you look now, that's on the western edge of the summit. I'm basically straddling it, so it's no wider than my normal gate width. There's the rubbish. And there's the end. So you could probably sit about 10 people along it. And that's the size of the summit of Mount Everest. We're almost there. So the descent is the most important part of the ascent. This should not be a one-way journey. This should definitely be a return trip. So I always get a return ticket. But you have to bear in mind that the hardest thing to get someone down who's having problems is that they still have to go up this section here and down the Hillary Step to get to the south summit, and then a very rapid descent. So the reason why we have less disasters on the south side compared to the north side on summit night in particular is that we actually have a much steeper summit day. It's much more steep. On the north side of the Tibetan or the northeast ridge, they start at 8,300 meters, so they're starting higher, they're spending more time at a higher elevation. Their summit day is probably just as long, 8 to 10 hours, but they only gain 500 meters and they only descend 500 meters. So it's a long, drawn-out ridge. Ours is much steeper. If we've got a casualty, we can drag them down to the South Col from the South Summit, if needs be. Wind picks up as the afternoon progresses. This is 2010, the second summit that year that I was lucky enough to complete. You can see one last climber going up. I think there's one person there coming down, but just 2 people left. And that was, I think, the last summit that year. This is 2012, and it's like a street scene from Manhattan. And they are so lucky that the wind did not pick up as normal. This should never, ever happen. And you can see them kind of squabbling over their Hillary Step. We came down a rope. This is the rope here, you can just see it. That's the rope we came down, and I have to say that was one of the most terrifying experiences of my life. Here at the top of the Hillary Step, it's a fixed line all the way around. You have to sort of take your harness. On that you have one piece of rope and a carabiner, and you're attached to the rope on one side. You unclip your Juma or your other carabiner, which is attached to a piece of rope on your harness, and you clip it around someone. So you're literally hanging out over a 2,500 meter drop. People who had no real climbing technique or expertise were thankful, helpfully they thought, unclipping me as I was going around them. So at times you were effectively just hanging in thin air, just by the grip of your hand. And so actually people were getting pretty shirty on that summit night or summit day. And this is a really bad vibe. And 4 of those people didn't make it down. And the reason being is they spent a lot of time waiting, and they didn't turn down their oxygen in anticipation for what was going to be a really long day. This is the last generation of oxygen mask. We now have the reservoir bag on the side of the mask. It works really, really well. And so the kind of science that's going into development of these masks is really incredible. So if we go through the generations, 2003, 2006, 7, 8, 2012, and there'll probably be something different waiting for me at base camp to work out in 2014. Almost the fighter jet pilot. So down we go, down, down, down. This is 2012. I looked at the time that this photo was taken. This is 6:30 in the evening. And actually when we zoomed up, we can see people on the southeast ridge way above the balcony. They're around 8,600 meters at 6:30 in the evening, having started at 8 o'clock the previous night. Here there's a bit of a commotion. If you zoom in up, it's probably the Canadian Nepali lady who died and didn't come down. But she was, touching distance to south of the South Col. Should never have happened. That's in 2003, feeling pretty happy with myself. A little plug, we go out to Everest Base Camp, not just to climb Everest, but to trek. And we are on Everest and Lhotse this spring, so if you are interested, we're on Facebook and Twitter. I'm a bit of a dinosaur when it comes to those kind of communications, but with Mary Kristelle's help, hopefully we'll be giving sort of regular updates of what we're up to on the mountain this year. So thank you very much for your patience. I know it's been a long evening now. I've dragged it out even longer, but thank you for attending, and I hope that's given you an insight on how to climb Mount Everest. Thank you.